In this video, we are going to talk about synthetic division. So we've already talked about polynomial long division. So basically, why are we talking about synthetic division? Well, first off, synthetic division is a little faster than polynomial long division. Most people kind of like it more once they learn it. Um, the thing is that synthetic division can only be used to divide by a first degree polynomial. So, for instance, those last two examples that we did in the polynomial long division video, those cannot be done using synthetic division. So you don't have any choice if you want to do that division. Okay, so um, just like with polynomial long division, with synthetic division, right, your polynomials have to be written in descending powers of x and filled in for any missing powers of zeros. Okay. Okay, so let's go with our first example. So in our first example, what we are going to do is, again, check our polynomials and make sure that they are in descending powers of x and that there are not any missing powers of x. And everything's good with these two. In fact, this is the same first example we did in the previous video. All right, and so everything's good. We don't need to do anything with that. So now, the way that you do synthetic division, right, is you only look at the numbers. Okay, so the setup is different. You know, with polynomial long division, you have to have the powers of x and everything like that. All right, so with this, we're just going to look at this polynomial and put a 1, oops, sorry, a 1, a 4, and a 1. Okay, so this is a 1 here, put a 4, put a 1. Okay, so that's what it's going to look like. And I'm trying to draw it like my notes. You'll see this drawn a lot of different ways in our notes. They're kind of drawn like this with the big bar. I have seen it like this, and I think that's the way that I originally learned how to do it. So sometimes I think I just default to that way. It doesn't matter. You kind of write it however you want to. All right, so that's this one. So the next thing, right, and this is often confusing for people, is that the number which you divide by. So a lot of people will see this number and go, okay, so I should put a -3 there, here, and the answer is no. You should actually put a +3 here. So however you set it up, it's either going to be set up like this or like this. Okay, and so now, why is it a +3? It kind of goes by the 0 that you would get if you set this equal to 0. So if I set x minus 3 equal to 0 and solve it out, I'll get x equals 3. Okay, that's the number that you should put right here. All right, so some people think of it as being the opposite. Hey, that's a -3, so I put a +3 here. Other people, sorry. Other people look at this as by what number makes this 0. Okay, so that's the setup. And that's can be a little bit confusing. All right, so that's what the setup looks like. This is the way that the software that I use to typeset this, it kind of automatically will do this for me, and that's the way it's set up. So that's just what we're going to go with. Again, it doesn't really matter how it looks. If I do this by hand, I think I almost always do it like this way right here. And then I put a line down here. So whatever, it's close enough. All right, so that's the setup and how you get it set up, right? And now the other thing about synthetic division, right, is the algorithm or set of steps, right, that you go through to do it is slightly different, right, than long division. So polynomial long division, the steps that you go through, you know, are kind of, you're more used to that because that's the way you do integer long division. That's the way they teach you, right, since elementary school about how to do that. But with this synthetic division, it's And I had the toughest time when I first learned this, trying to not do it the same way as I did with regular division. So in my mind, I think multiply and add. Those are the two things that you are going to do, right? Multiply and add, multiply and add, multiply and add, okay? Okay, so what do you do to kick off synthetic division is you bring the 1 down. So this one just drops straight down. You don't do anything with it. Okay, and then after you bring that down, that kicks off this multiply and add phase. So you're going to multiply. 3 times 1 is 3. That number goes here. So multiply and add. Okay, multiply and add. All right, so next up, 3 times 7, I'm going to multiply and add. Okay, and that's it. We're done, right? So you can see the appeal of synthetic division over polynomial long division. It's quicker, right? Once you get used to what you have to do, then it's really, really fast, okay? Faster than polynomial long division. You have to write less. Everybody likes that, okay? All right, so the next thing is, okay, so let's go over here and you'll see the result, right? There's what I had. The next thing about polynomial long division is, okay, how do I write my answer in the mixed number format, okay? So what you're going to do, right, is this last number right here is always the remainder, okay? Always. All right, and so then how do you get the other part? Okay, the other part, right, is that this polynomial that we divided by, right, was x squared. It was a second degree polynomial, okay? So what happens when you do synthetic division, because you're always dividing by a degree 1 polynomial, the quotient, right, this part right here, always has a power 1 less than what you started with. The power drops by 1, right? So here, this was the number with x squared, this was the number with x, and that was the constant term, right? So it drops by 1. So this will be the number with x, and then this will be the constant term. So x squared, our original problem, right, was x squared plus 4x plus 1 over x minus 3 and so here this will be 1 times x, which I'm just going to write as x, plus, and then this is the constant term 7. Now say you were starting out with an x cubed up here, a third degree polynomial, then your answer would be a second degree polynomial, and it would be the first number times x squared plus the second number times x plus the constant term, okay? But here we have a degree 2 polynomial, so this winds up being a degree 1 polynomial. All right, and then the remainder over what we were dividing by, which was x minus 3. And if you go back and look at the polynomial long division video, that's exactly the same answer that we got for that problem, okay? All right, and so here we are, right? That's the answer that we got on here. All right, next example. Oh, yes, something else we need to illustrate here. Okay, and this is important coming up. So it says just for the fun of it, right? And really not for the fun of it, right? Because I want to show you something. Plug 3 into the first polynomial. So I'm going to plug 3 in here. When I do that, I'll get 3 squared plus 4 times 3 plus 1 equals 9 plus 12 plus 1 equals 22. right? So when you see that for the first time, you say, hey, well, wait, there's a 22 right here. Is that a coincidence that they are the same? And the answer is absolutely not a coincidence. That actually should happen every single time, right? So if you take this number right here and plug it into this polynomial, right, this one right here, that what you get should be exactly the remainder. Okay. All right. Next example. All right, in this example, we want to divide x to the third plus 2x squared minus 3x minus 1 by x plus 2 using synthetic division. Okay, so we need to double check, are our polynomials written in descending powers of x? Yep. Are they missing any powers of x? Nope. Right, so we are good to go. And so we are ready to write this in our synthetic division format. So it's going to be 1, 2, minus 3, minus 1. And the number up here is going to be a minus 2. Okay. Minus 2. Remember, that's because it's either opposite of what you see here. Right? Here I see a positive 2, so it's going to be a negative 2. Or the way to think about it is if you set that equal to 0 and solve it, what would you get? And you would get a minus 2, right, when you do that. In other words, minus 2 is the 0 that would come from setting x plus 2 equal to 0 and solving. Okay, so this is going to be our setup. All right, now we are ready to roll. Bring down the 1 to kick things off. And remember, it's multiply and add. Minus 2 times 1 is minus 2. Add. All right, then multiply. Negative 2 times 0 is 0. Add. Multiply. Negative 2 times negative 3 is a positive 6. Negative 1 plus 6 is a positive 5. And that's it. All right, so we're done with our synthetic division. What we want to do is to write our answer, okay? So our answer, right, what we started with was a degree 3 polynomial. We did synthetic division, right? And so what that means is that the answer down here will be a degree 2 polynomial and the remainder, right? So this will be the number with x squared this time. This will be the number with x. And this will be the constant term, and this, as always, is the remainder, okay? So our answer is going to be x squared plus 0x, which is really no need to write, but I'm going to write it right now anyway, minus 3, right, plus 5 over x plus 2, what we were dividing by. Okay. Okay, so this is the answer here. All right, so next up, let's plug in a minus 2 into the first polynomial, this polynomial right here. And really, we know what's going to happen, right? We know that we will get a 5 right here, the remainder. Okay, but let's go ahead and do it anyway. So we plug in the negative 2. So that would be negative 2 cubed, 2 times negative 2 squared, minus 3 times negative 2 minus 1. So negative 2 cubed is negative 8. Negative 2 squared is positive 4 times 2 is 8. And then negative 3 times negative 2 is a positive 6 minus 1. So we wind up with positive 5, right? Exactly the remainder. Okay, and again, no coincidence on that. Okay, and so that brings us to the remainder theorem, right? The remainder theorem says that if a polynomial p of x is divided by x minus r, either synthetic, right, or in polynomial long division, the remainder is p of r. So that is whatever you get when you plug r into the polynomial. That's going to be exactly the same thing as the remainder when you divide by x minus r. All right, and that's it for this video.